Okay, we're going to investigate algebra with manipulatives. So I'm placing out a number of different colored rods and squares and rectangles and cubes. We're going to investigate the relationship. We even have a bigger cube and something that's like a box. It's not exactly a cube. So we want to see what the relationship is between all of these different objects that I have here on our screen. We're going to start with the simplest object, our green. So we have nothing really to say to this except we're just going to arbitrarily say that this is our unit. And we're going to call it 1. That's what our units are 1, 2, 3. So that's 1. That's 2. That's 3. That's 4. I think you get the idea. So we're going to call our units, we're going to call them 1. So we're going to remember that our green is equal to 1. Let's compare our green units to our yellow rod. What's the relationship? You might think it's 3. Well, let's test it out. If you look closely, you can see that 3 rods do not equal 1 yellow. There's a gap here. So that means yellow does not equal 3. Well, we have no way of really knowing what yellow equals because we have no way of measuring it outside of our green cubes. So let's see. If we don't know what something is, it could be anything. So what do we call things in algebra that are unknown that perhaps we have to solve for? We call them x. Usually, we can call them other things. But we're going to call this x because we don't know how long that is. What about our orange? Right, well, we can see that our orange is definitely longer than our yellow, which we called x. But it's certainly not 2 yellows. Well, let's check the green again. Definitely not 4 green. And it's not 5 greens. So once again, we don't know what our orange is. But we can't call it x because x is our yellow rod right here. We didn't know what our yellow rod was either, and we don't know what our orange rod is. If I call my orange rod x, I have a problem. I'll be saying that my orange rod is the same as my yellow rod, and they're not. So what do? Well, we have more letters in the alphabet, so why don't I just call this y? So I'm going to call my orange rod y. So just when I think I have it all figured out, I have a new thing I have to consider. So while considering this, I have to see, well, how am I going to figure this out? Well, let's see. The width is the same as x and the length is the same as x. So I know that this side has the value x and I know this side has the value x, right? Because we said that was the length of x and that was the length of x. Well, that would mean then that this is the area. How do we find the area of a square? Well, we take x times x. So that means that we have x times x equals x squared. And that's definitely a square. No doubt about it. That's why when we have an exponent that's the number 2, we call it a square, because we get the shape of a square. Well, let's look at this one. This is also a square. Let's try this on the side since it's the same color. Look at that. That is the length y. And that is the width y. So it's the same sort of thing as with our x squared. So that means that this side is the length y. And this side is also the length y. So how do we find our area? Well, our area is y times y. So that means we have y times y, which equals y squared. So y squared goes with that. We have another shape I want to look at, and that's this one. Definitely not a square. So how are we going to figure out what it is? Let's use the same process we did with the others. This is going to be a little harder because notice this is a different color than the other ones. We kind of figured out that yellow went with yellow and orange goes with orange. We kind of figured that out. But this doesn't have any colors that match. Well, I could try this. A yellow. Let me see what happens if I put a couple green in there, if I can get that to work. That doesn't work. Okay. So let's try a Y. Cool. That works. So we know that this distance, that side length, is y. What about this side length? Well, let's try the yellow, because that looks a little shorter. Perfect. Look at that. So that means then that this side is y, and this side is x. So to find our area, we know that we're going to have x times y, which equals xy, belongs to that.